Okay, we're still working on section 1.1, and we're looking at some review materials in that, and we're just looking at now special triangles here in this question here on the bottom here. As you can see, I've got two questions there, two different triangles, pictures drawn, and I would like you to use the special triangle relationships in order to calculate the missing values. So the first one here is a 30, 60, 90 degree triangle here. So what I'm going to do is on the inside of the triangle, I'm going to draw or write the unit that would be there from the reference triangle so that we can then do a ratio or a relationship, or if you like, a cross multiplication to calculate our answer. So if we look at the special triangle 30, 60, 90 degrees, the one value is usually here. The two value is usually the hypotenuse here. Well, not usually, it is. And then inside is here. So that's my ratio inside. Now the outside is the actual number. So now we can do a ratio of inside to outside. So starting from 1 to 5, is the same thing as saying 2 to y. And 1 to 5, okay, 1 to 5, I'm going 1 to 5, and then I'm going to be equaling it, and then I start inside. I want to do the x now, so I go root 3 to x. So then I do my cross multiplication. So if I do my cross multiplication, y here equals 10, and here we have x equaling 5 root 3. Okay, so fairly simple. Okay, you can get a little more complex example. Here we have finding x, y, and z. Z being here, x being here, and y being this here one. So we can, again, put inside the circle our, inside the triangles, our basic relationship. So I'm just going to draw a little triangle inside this one like this so that I don't get confused with my 5 there. Okay, this is my 30 and that's my 60. So again, if I'm looking at my special triangle relationship, we know that the angle or the side opposite the 60 degrees is the root 3. The hypotenuse is the 2, and the short side opposite the 30 degree angle is usually the 1. So the 1 is there. Okay, so having that figured out, I could then calculate this side here and this side here, which will then help me. Now, having said that, for the inside of the 45-45 triangle, it's just simply 1, 1, and root 2 here. So we know that 1 is to 5 as 1 is to x. So this means x is 5. So we have a value for this at 5. Just going to circle it there. Now, if I do a ratio to find the z now, which is what I'm going to do here. Okay, outside here we have 1 is to 5, inside to outside, is equal to 2 is to z. So we have z equaling 10. Okay, very similar to what we did here. Now we have to find this piece here, and then we have to add it to this piece here. So in order to find this piece here, we can say, let's say, call this value something totally different. Let's call it capital A. Okay, so we can do a ratio, 1 is to 5, inside the 60, 30, 90 degree triangle. 1 is to 5 as root 3 is to A value. So when A value here is going to be our 5 root 3. Okay, and now to get the total value of y is equal to 5 plus 5 root 3. Okay, so that's our total value there. Now we could change it to a decimal, but we can leave it as that. Okay, and that concludes the examples from the first review section. Now also in the review section, there's a nice table there On page 4 are the exact values of the trigonometric functions. You should keep that in mind at all times. And also remember the signs that occur inside the quadrants, where they're positive and where they're negative and so forth. So keep in mind on page 4 that trigonometric table for values of 30 degrees, 45 degrees, 60 degrees, 0 and 90 degrees when you're dealing with the special triangles. We'll need those later on in the chapter.